Have you ever just looked up at the night sky and had that thought, where is everybody? It's this huge, nagging question in science, and we call it the Fermi Paradox. Well, today we're going to dig into a really fascinating, kind of elegant solution to it. One that doesn't come from biology or sociology, but from physics, all based on a brilliant paper from 1994. All right, let's get into it.
So, to really get a handle on this paradox, we first need to wrap our heads around the sheer, mind-boggling scale of the silence we're trying to figure out.
It all kicked off with this really simple question. The story goes that the physicist Enrico Fermi just blurted it out over lunch one day. He was thinking, given everything we know about the universe, why haven't we found anyone? It sounds so simple, right? But that one question has basically stumped some of the smartest people on the planet for decades.
Okay, let's just talk numbers for a second to put this in perspective. Our own galaxy, the Milky Way, has at a minimum 100 billion stars, and it's been around for over 13 billion years. That is just an insane number of opportunities for life to pop up and for civilizations to get going.
And that right there is the heart of the problem. Even with technology we can kind of imagine, just traveling at a tiny fraction of the speed of light, it would only take a few million years to colonize the entire galaxy. I mean, that's nothing in cosmic time. It's a blink of an eye. So the galaxy should be full. It should be buzzing with activity. But when we look out, all we hear is silence.
So how do we explain this silence? Well, people have come up with a lot of theories. The usual suspects, you could say. But as we're going to see, they all share one critical, fatal flaw.
You've probably heard a bunch of these before, right? Maybe advanced civilizations always nuke themselves into oblivion. Or maybe they just get super advanced and lose interest in expanding. Or, the zoo hypothesis, that we're in some kind of cosmic nature preserve. They're all cool ideas, but they've all got a huge problem.
And this is where Jeffrey Landis just hits the nail on the head. He points out that all these theories assume what he calls a uniformity of motive. I mean, for any of these to be the answer, it means that every single alien civilization, for billions of years, has to make the exact same choice. Every single one.
And that just seems wildly unlikely, doesn't it? I mean, think about how diverse cultures are just here on Earth. All it would take is one. Just one civilization out of potentially billions to say, you know what, let's go. And the whole theory falls apart. The galaxy would be colonized. So we need a better answer, one that doesn't depend on us trying to guess what aliens are thinking. And this is where the paper gets really, really clever. It completely shifts the focus. It stops asking why aliens might colonize, and instead starts asking how that colonization would physically spread through the galaxy.
Landis suggested we use a concept from physics called percolation theory. Now, stick with me here, it's actually pretty simple. Imagine you're making drip coffee. As you pour water over the grounds, some parts get wet and let the water seep through, but other little pockets stay dry. Percolation theory is just the math that describes that kind of patchy, random spread.
Let's use a forest fire analogy because it makes it super clear. So a civilization decides to start colonizing. That's our first tree catching fire. It sends out colonies to nearby stars. Those are the sparks flying to other trees. Now, each new colony grows up and develops its own culture. And this is the most important part. It has to decide for itself if it wants to keep expanding. So does that new spark ignite another tree, or is the wood too damp to catch? The spread isn't some uniform wave. It's a chain reaction that can stop and start and fizzle out.
Now, for this model to work, we don't need to know a thing about alien philosophy or art or politics. It all just boils down to two really basic kinds of behavior.
You basically have two types of cultures in this model. You've got the colonizing cultures who are driven to expand, and you've got the non-colonizing cultures who are perfectly happy to stay put. That's it. The colonizers spread out, but when one of their colonies ends up next to a non-colonizer, that particular branch of expansion just stops. The non-colonizers act like a natural fire break.
The whole model then kind of hangs on this one single number, p, which is the probability that any new colony will also become a colonizing culture. Now, Landis is upfront, there's no way we can know this number for sure, but he makes a pretty reasonable guess. He figures any civilization has three basic outcomes. They blow themselves up, they decide to stay home, or they expand. So a 1 in 3 chance of becoming a colonizer seems like a pretty fair place to start.
And here's where it gets really cool. Depending on what that one number p is, this super simple rule can create three completely different looking galaxies. And in all three of these scenarios, there's a totally plausible reason for us to be alone.
Okay, first up, what if that probability p is really low? We call this subcritical. In this case, colonization just never really gets off the ground. It's like trying to start a fire with
bunch of wet logs. You might get a few small, isolated clusters of colonized stars, but they die out really fast, leaving almost the entire galaxy completely empty. If that's our universe, we're alone simply because we're way outside one of those tiny, rare clusters. Now, what if the probability is super high? This is the supercritical state. The opposite happens. The fire just rages across the whole forest. The entire galaxy becomes one giant colonized region. But, and this is the key, percolation theory tells us it won't be a perfect fill. By pure chance, there will be these small, isolated pockets, voids, that just got missed. In this scenario, we're alone because we just happen to be living inside one of those rare, empty bubbles.
But the most interesting case is what happens if the probability is balanced right on a knife's edge, that critical tipping point. When that happens, the galaxy doesn't fill up, but it doesn't stay empty either. It becomes a fractal. You get this incredibly complex pattern of vast, sprawling regions that are totally colonized, right next to equally vast regions that are totally empty.
So let's just lay it all out here. You can see the three possibilities. Whether the galaxy is mostly empty, mostly full, or this complex fractal mess. In every single case, our solitude is statistically possible. There's a natural, mathematical reason for Earth to be isolated. And you'll notice we haven't had to make a single assumption about what aliens think or want.
And here is the punchline. Remember that 1 in 3 guess for the probability? Well, it turns out that for the density of stars in our neck of the woods, a probability of 1/3 puts our galaxy right on the edge of that critical state. It suggests that our galaxy could be naturally filled with enormous empty regions, and we just happen to be in one of them.
So let's tie all this together. What does percolation theory really tell us about the Great Silence?
You know, the true beauty of this whole approach is its simplicity. It just throws out all those messy, impossible-to-answer questions about alien psychology and replaces them with the clean, predictable logic of statistics. We don't need every alien civilization to act the same. In fact, the model works because they're different.
This just completely reframes the entire paradox. Maybe this silence isn't some ominous sign that something is wrong, that life is super rare, or that all civilizations are doomed. Maybe this silence is just a feature of the system. It's a natural, predictable outcome of how things spread across huge spaces over huge amounts of time.
And that leaves us with a pretty wild thought to end on. Perhaps the silence we're hearing isn't really evidence of absence. Perhaps it's just the sound of our own cosmic neighborhood. We might not be uniquely alone in a crowded galaxy, but just residents of a vast, empty, and perfectly normal chunk of space.